Right, surface area. Before we deal with surface area, we need to deal with area, and so some quick review. Often when you see a shape, you're going to see little tick marks in the sides of it. If it's like this and it's the same number of tick marks in each side, it tells you all four sides in this case are all the same. So in this case, this is a square. And we're going to say that this is 3 centimeters. All right. Now, because it's a square, I don't need to write 3 centimeters next to all of the sides because these little tick marks tell me that each side is the same. So if I want to find the area of this square, area of a square is equal to, and we need to know this formula, side length, so S squared. Area here, so second step, you're going to substitute in the actual value for the side length. So in this case it is 3 centimeters. And we're going to square that. And then we solve that. 3 times 3 is 9. And the units are going to be centimeters squared. Lovely. This takes us on to our rectangle. Rectangles have opposite sides that are the same. And so similarly, we're going to have tick marks in them sometimes to show that this side and this side are the same, this side and this side are the same. All right, we're going to say that this is 7.5 centimeters. And this is 3 centimeters. Formula, again, we always start by writing the formula. Area is equal to, length times width. Area is equal to, it doesn't matter which number you use for length. I always use the bigger one for length. That's just me. But again, as long as you're being consistent, within a given shape, you're fine. So 7.5 centimeters times 3 centimeters. And then again, I solve here, so 7.5 times 3. My calculator should be telling me that that is 22.5. And I include my units, which are going to be centimeters squared. And away I go. Move on to triangles. Many different kinds of triangles. Honestly, grade 9 stuff, you're going to mostly see isosceles or right angle triangles. The odd time you might get a different one. The formula, however, for all of them is the same. It's going to be, and I'm showing this on purpose before I put numbers down, area is equal to base times height divided by 2. Alright, so in this case, if my base of this lovely triangle is, let's go with 4 centimeters. Oh, that was not a nice M. Oh well. And my height. Now the height is from here in a straight line up to the point. So it's this straight line from the point down to the base. It's not the distance up the slant height. It is this distance from here to here. So the height here we're going to say is 6 centimeters. That's all I need to figure out the area of this triangle. So area is equal to 4 centimeters times 6 centimeters divided by 2. And getting to be a little bit trickier, but still not really all that bad. 4 times 6 is 24. 24 divided by 2 is 12. Area here is going to be 12 centimeters squared. Okay, now, triangles sometimes can be a little bit trickier than this. Sometimes you're going to get, and I'll just scroll down here a little bit to show what's coming, something like this. Here we have a lovely triangle, 4 meters by 4 meters by 4 meters. I don't have a height. That's a moderate problem. So I'm going to actually solve this already up here. So imagining I have a triangle. Slant height is 4. Base is 4. Other slant height also is 4. This is an equilateral triangle. I guess I could have these little ticks on it if I wanted. I need to know the height, and it's not 4. But now, what I can do is I can draw this line for the height down here. And now I can split this into 2. So if the total distance from side to side, the whole base, here to here, is 4, each of these is going to be 2. And if you think back to grade 8 math, you dealt with the Pythagorean theorem. Or if you've got a right angle triangle, which each side of this lovely thing is, this shorter length squared plus this shorter length squared gives us the hypotenuse, the long side squared, if I add them together. So I have the long side, I have one of the short sides. The way this is going to look is if we imagine our triangle as a right angle triangle just by itself, labeled A, B, and C. We normally would write A squared plus B squared equals C squared, right? So let's just do that for a moment. A squared plus B squared equals C squared. That's kind of the Pythagorean formula. But if I need to solve for B or B squared, I can subtract A squared from both sides, and I'm going to find out that B squared is going to be equal to C squared minus A squared. Alright, so B squared is equal to C squared minus A squared. I don't know what B squared is. Then I guess I can also simplify this one more time. B is equal to the square root of C squared minus A squared. There's my formula. Not nice, but this is going to give me the B for this triangle. So B equals the square root of 4 squared minus 2 squared. B, ooh, that's not a pretty B, is equal to, so we'll take 16 minus 4, and then take the square root of all that, which is going to be equal to the square root of 12, which is not a pleasant, nice decimal, but we deal with it. And so in this case here, we've got the square root of 12, which you're going to need a calculator for, unless you have an absolutely fantastic memory, which most of us don't, and that's okay. 3.464101615. Couple things here. Writing that whole number down a whole bunch of times is really annoying. So what we're going to do is we're going to usually, in this case, there's no decimal points in the question. We're going to round in the end, at the very end of things, to the nearest whole number. However, I'm going to just include for this point 3 more decimal points, up to the second 4. 3.464 centimeters. So the height, all of that work gets us the height of this thing. Now I can find out the area, right? Area is equal to base times height divided by 2. So the height is equal to this b here. So this thing is 30.464 centimeters. Again, area is base times height divided by 2. Base times height divided by 2. Don't get confused with this b and this b. They both refer to different things. This is in terms of just the triangle stuff. And then this b here is the base. So now I look back and find out, oh, okay, the base of my triangle is 4 centimeters. So area is equal to, or sorry, 4 meters, I guess was this one. 4 meters times 3.464 meters divided by 2. That is not super pretty until now. Running out of space. Area is equal to, and we're going to go 4 times 3.464 into our calculator. We end up with 13.856, and then I have to divide that by 2. 6.928 meters squared. Right. So, easy one is if you already are given the height. Harder one, or at least longer one, is if you're not given the height, you're just given the slant lengths. Then you got to use Pythagoras to calculate the height. So, here we go. Let's move on to the circle. Circle, by comparison, is quite nice. The area of a circle, if I know the radius, is equal to pi times the radius squared. Area here is equal to pi times 2. Oh, we're going to pretend this is centimeters. 2 centimeters squared. Area is equal to pi. Now I can use the pi button on my calculator. All you need to use for the PAT is 3.14, so we're going to just go with 3.14 times 4 centimeters squared. I'm simplifying. I'm doing my exponents here already. And 3.14 times 4 is going to be 12.56, so the area of this circle is 12.56 centimeters squared. All right. This takes us now on to actually surface area, which you did learn about in grade 8 with simple kinds of shapes. So surface area is simply the area on the surface of a three-dimensional object. And then the question here, what would be the quickest way to determine the surface area of a rectangular or triangular prism? And quickest doesn't mean it's always going to be super fast, but it's going to be look for, there's a few steps here, but we're going to look for sides that are the same. All right? That's the big thing, is we're looking for sides that are exactly the same. And find the area of each side. And if we've got 4 or 5 or 3 or 2 sides that are exactly the same, we multiply those ones. All right? I could, right? There's on this lovely triangular prism, there are in fact 5 sides. I could do each of them separately. It's doable. can also realize, hey, look, there's two triangles here. These two triangles are the same. So I find the area of one and I just multiply by 2. Then I look and say, hey, look, there's 3 rectangles. They're each 4 meters by 11 meters. I can find one of them and multiply by 3. Look for sides that are the same. And then there's another couple little, just some tricks to go with this here. So you want to look for sides that are the same. That's the first thing. Secondly, show all your work. And thirdly, label which formula is for which side or sides. All right. For these little guys here that we're going to look at, this is not super important. When you get to shapes, like you will in the next couple days, that may have 4 or 5 different parts to them, and sometimes more, labeling things, super important. All right, so let's take a look and find the surface area of this triangular prism. All right, so what I'm going to do is I got to find my triangles. And I usually I'm going to write down triangles. And there's going to be, and I'll write times 2, because I see that there's 2 that are the same. And then I'm going to also look for the rectangles. In this case, there's 3 of them the same. So it's going to be rectangles. Times 3. Ooh, that is an interesting E that turned into an S. Times 3. Alright, so in this case, the triangle's area is equal to base times height divided by 2. And remember, we did the work up on the last page for what the height is. The height of this lovely triangle was 3.464. We actually found the area up there, but we'll copy it down here again. So base is 4 meters times the height is 3.464 divided by 2. So the area of one triangle is going to be equal to, I punch that onto my calculator, I end up with 6.928. 928 meters squared. And then I have to go, triangles, I need to have 2 of those. So what we might look at is, say, total equals this 6.928 meters squared times 2. And that's going to be equal to 13.856. And I will put a little box around this so that I know later on I'm going to have to add this onto whatever I get for the rest of things. So in this case, I've got 3 more rectangles. Each of these rectangles is 11 meters by 4 meters. Right, there's the top and then the left side and the right side. Area is equal to length times width. I write down my formula. Area is equal to, and I always find for just one of them, length is going to be 11 meters times 4 meters. This is a fun math that I can do in my head. Area here is going to equal 44 meters squared. And then I have up here, I've got this times 3, so my total is 44 meters squared times 3. And 44 times 3 in my calculator gives me 132. Put a little box around this. Okay, that's part of what I need. And then finally, in the end, my surface area is just adding everything up. So my surface area is going to be this 13.856 plus 132. Right? Okay, I could say, if I really wanted to make this into a formula, surface area equals triangles times 2 plus rectangles times 3. So my surface area, and I figured this all out here. Surface area equals 15.8. That's not a great equal sign. 856 meters squared plus 132 meters squared. And my surface area equals plus 132, 145.856. Meters squared. Lovely. Now, at this point here, all of my measurements are with no decimal places. I can now round this to the nearest whole number. So 145.856 is closer to 146 than 145. So I round it, and my final answer is surface area is equal to 146 meters squared. Circle this because it is my final answer. And I'm done. One of the things you should see is surface area looks like it's a small question, and it becomes lots of work that you have to show. Get used to it. Don't be lazy. Show all your work. All right. Now, here we've got a box. Rectangular prism, if you'd like. There is a formula for this. But essentially, the formula is saying we need this front and back, 2 times the front and back. Sides, we need 2 times the sides. Top and bottom, which is the same, 2 times that. So surface area equals, right, top times 2 plus the bottom times 2. No, sorry, the top times 2 gives me the bottom. Top times 2 plus sides times 2. Plus the front times 2. Lovely. Now, if you want the formula, surface area equals 2LW, 2 times length times width, plus 2WH, width times height, plus 2H L, height times length. And I do not need to have brackets around them. Sorry, I put them there. All right, so here we go. Before I start using, if I use this formula, label which is which on my, right? So this is height, 12 centimeters. That makes pretty good sense. I'm going to call this length. I call this width. Right? I label them just so that when I start using them, I don't get mixed up. Plug them in. Surface area equals 2 times LW. And again, I put my numbers in. I'm going to run out of space here, aren't I? 4 centimeters times 3 centimeters plus 2 times my width times my height, 3 times 12. Plus 2 times height times length. Two times 12 times 4. Alright, so my surface area, this is a nice one because it does sort of do everything at once. 2 times 4 times 3 is 24 centimeters squared. Plus 2 times 3 is 6 times 12 is 72. Let's try it again. 72 centimeters squared. Plus 2 times 12 times 4. Oh, what do we got going on here? 2 times 12 is 24 times 4 is 96 centimeters squared. And then I just got to add these up. 24 plus 72 is 96. 96 plus 96 is 192. Okay, so surface area is 192 centimeters squared. Right, could I have figured out this rectangle, right, the sides, and the other times 2, front and back, times 2, top and bottom, times 2? Yeah. When I add them up, I'd end up doing the same thing as I just did here in my formula. Surface area of a cylinder. All right. So if we imagine we've got 2 circles, and we've got this cylinder face. Now, if you can imagine unrolling that or cutting it apart, it would roll out to be a rectangle. And the dimensions of the rectangle would have the height of the can, height of the cylinder, sorry, by the distance around the circle. Oh wait, the distance around the circle is called the circumference. So, surface area of a cylinder two times the circles plus the sides. Okay. So my formula is going to look like surface area is equal to 2 times the circle. So 2 times pi r squared plus. Well, if we roll this out to be a rectangle, the distance around is the circumference, and that's pi times d. Right? And that's the one side of our rectangle. The other is the height times h. So plus pi times D times H. All right. In this case, we have to remember that the radius is half the diameter, so I need radius here, I need diameter here. So in this particular case, radius is 1.5 meters. Okay, so my surface area is equal to 2 pi times 1.5 squared plus pi dh. Pi times the diameter, which is 3 meters, times 7 meters. Pi times 3 times 7. There we go. That's my height. And so now I just got to do some calculator stuff. I would recommend doing the 2 pi r squared part and then doing the pi dh part separately. So we've got, oops, come back. 2 times 3.14 times 1.5 times 1.5 is what I actually type into my calculator, because I know that 1.5 squared is just 1.5 times 1.5. So 2 times 3.14 times 1.5 times 1.5 in my calculator. This part is 14.13 meters squared, not centimeters squared. Sorry, meters squared, plus pi times 3 times 7. Well, 3 times 7 is 21. 3.14 times 21 equals 65.94 meters squared. And now I can add up the whole thing finally. So SA for surface area is equal to 14.13 plus 65.94. And we get 80.07. Notice again that all of my measurements are in whole numbered meters. So I should get my answer in the same decimal place. So surface area here equal to 80 meters squared. There we go. We have solved our problem. Okay, a lot of this should be review. Brief little assignment we'll be giving you to